Question 1. What is the primary purpose of model approval in MLOps? Option A. To technically validate a model's performance metrics exclusively. Option B. To formally review a trained model for quality, performance, compliance, ethical considerations, and business readiness before deployment. Option C. To automate the retraining process of machine learning models. Option D. To manage the storage and versioning of raw training data. The correct answer is to formally review a trained model for quality, performance, compliance, ethical considerations, and business readiness before deployment. Here's the explanation. Model approval acts as a critical governance checkpoint, ensuring models meet predefined criteria for quality, performance, compliance, ethical considerations, and business readiness, aligning with organizational objectives, regulatory requirements, and responsible AI principles before production deployment. Question 2. Which of the following is a key component of the model approval process involving non-technical stakeholders? Option A. Automated evaluation of RMSE and AUC scores. Option B. Security scans and vulnerability checks on the model artifact. Option C. Stakeholder review and formal sign-off from business owners and compliance officers. Option D. Continuous monitoring of model performance in production. The correct answer is stakeholder review and formal sign-off from business owners and compliance officers. Here's the explanation. The model approval process explicitly involves a workflow for relevant stakeholders like business owners, legal, compliance, and ethics committees to review the model and provide formal approval or rejection, distinguishing it from purely technical assessments. Question 3. In the context of MLOps, what role does a model registry typically play in the model approval workflow? Option A. It performs the automated bias and fairness assessments. Option B. It serves as the primary tool for generating explainability reports, XAI. Option C. Approved models are registered here, marked as production ready, with comprehensive metadata, enabling seamless deployment. Option D. It is responsible for continuously retraining models based on new data. The correct answer is approved models are registered here, marked as production ready, with comprehensive metadata, enabling seamless deployment. Here's the explanation. Approved models are typically registered in a centralized model registry, marked as production ready, with comprehensive metadata, enabling seamless deployment by CI/CD pipelines. The model registry is the central hub for managing the status and metadata of models throughout their lifecycle. Question 4. What is the primary objective of model promotion in an MLOps context? Option A. To solely focus on code versioning for machine learning applications. Option B. To systematically move a machine learning model from development through various testing and staging environments to production. Option C. To archive retired model versions and their associated data. Option D. To optimize the computational resources used during model training. The correct answer is to systematically move a machine learning model from development through various testing and staging environments to production. Here's the explanation. The overview states, model promotion in MLOps refers to the systematic process of moving a machine learning model from a development or experimental environment through various testing and staging environments, ultimately to a production environment where it serves real-world predictions. Question 5. A data science team wants to deploy a new version of their fraud detection model with minimal risk. They decide to first route a small percentage of live transaction traffic to the new model, observing its performance and impact before gradually increasing the traffic. What deployment strategy are they employing? Option A. Blue/green deployment. Option B. Canary deployment. Option C. A/B testing. Option D. Shadow deployment. The correct answer is canary deployment. Here's the explanation. The study material describes canary deployments as gradually rolling out a new model to a small subset of users to observe real-world performance and impact without affecting the entire user base. Question 6. Which MLOps component serves as a centralized repository for storing, versioning, and managing machine learning models and their metadata, acting as the single source of truth for all model versions eligible for promotion? Option A. Feature store. Option B. Data lake. Option C. Experiment tracker. Option D. Model registry. The correct answer is model registry. Here's the explanation. The key features/components section explicitly defines model registry as a centralized repository that stores, versions, and manages machine learning models and their metadata, acting as the single source of truth for all model versions eligible for promotion. Question 7. What is the primary goal of implementing model rollback in an MLOps pipeline? Option A. To continuously update a model with new data to improve its performance. Option B. To provide an immediate recovery path by reverting a deployed model to a previous, known good version. Option C. To automatically tune hyperparameters for optimal model performance. Option D. To scale up the model's inference capacity during peak loads. The correct answer is to provide an immediate recovery path by reverting a deployed model to a previous, known good version. Here's the explanation. The overview states that model rollback is a critical safety mechanism, 2. Rapidly reversion of a deployed machine learning model to a previous, known good version to mitigate risks of new deployments. Question 8. Which two MLOps components are sometimes most essential for enabling an effective model rollback strategy? Option A. Hyperparameter tuning and continual learning. Option B. Model registry and monitoring and alerting systems. Option C. Data versioning and feature store. Option D. Resource management and CI/CD for ML. The correct answer is model registry and monitoring and alerting systems. Here's the explanation. The key features/components, section lists, model registry as fundamental for identifying and retrieving previous stable versions, and monitoring and alerting as crucial for detecting issues that trigger rollback. Question 9. A new model version is deployed using a blue/green strategy. Shortly after, monitoring systems detect a critical increase in error rates. How would an automated rollback typically be executed in this scenario? Option A. The model would be immediately retrained with new data. Option B. Traffic would be switched back from the green environment, new model, to the blue environment, previous stable model. Option C. The problematic model would be deleted, and a data scientist would manually redeploy an older version. Option D. The model's hyperparameters would be automatically retuned in the green environment. The correct answer is traffic would be switched back from the green environment, new model, to the blue environment, previous stable model. Here's the explanation. The how it works and comparison/related concepts sections explain that with blue/green deployment, rollback involves simply switching traffic back to the original stable environment. Question 10. Which of the following best describes the primary goal of model governance within an MLOps environment? Option A. To solely automate model deployment pipelines for faster releases. Option B. To manage the entire lifecycle of ML models responsibly, transparently, compliantly, and ethically. Option C. To exclusively focus on optimizing model performance metrics in production. Option D. To ensure all data used for training is perfectly clean and free of errors. The correct answer is to manage the entire lifecycle of ML models responsibly, transparently, compliantly, and ethically. Here's the explanation. Model governance encompasses the comprehensive set of policies, processes, and tools designed to manage the entire lifecycle of machine learning models in a responsible, transparent, compliant, and ethical manner, extending beyond mere technical deployment to strategic oversight and operational control. Question 11. Which component of model governance provides a centralized repository for all models, storing metadata such as purpose, owner, version, and training data? Option A. Audit trails and logging. Option B. Performance monitoring and alerting. Option C. Model catalog or registry. Option D. Explainability, XAI, tools. The correct answer is model catalog or registry. Here's the explanation. A model catalog or registry is described as a centralized repository for all models, storing metadata such as purpose, owner, version, training data, performance metrics, lineage, and deployment status, serving as a single source of truth. Question 12. In the context of MLOps, how does model governance typically integrate into the deployment process for critical models? Option A. By completely automating all deployment decisions without human intervention. Option B. By solely focusing on A/B testing different model versions post-deployment. Option C. By incorporating automated checks and manual approval gates within CI/CD/CT pipelines. Option D. By only monitoring infrastructure resource utilization during deployment. The correct answer is by incorporating automated checks and manual approval gates within CI/CD/CT pipelines. Here's the explanation. The study material states that deployment pipelines with gates are part of how model governance works, often including automated checks and manual approval steps for production deployments, especially in regulated industries, ensuring human oversight. Question 13. What is the primary reason for the necessity of model retirement in MLOps? Option A. To reduce the number of active model versions in a model registry. Option B. To ensure that deprecated or underperforming models do not continue to consume resources, provide inaccurate predictions, or introduce compliance risks. Option C. To solely make space for new, larger model artifacts in storage. Option D. To simplify the process of A/B testing new model versions. The correct answer is to ensure that deprecated or underperforming models do not continue to consume resources, provide inaccurate predictions, or introduce compliance risks. Here's the explanation. The overview states, the necessity for model retirement arises from various factors. A robust model retirement strategy ensures that deprecated or underperforming models do not continue to consume resources, provide inaccurate predictions, or introduce compliance risks. Question 14. A manufacturing company's predictive maintenance model, which forecasts equipment failures, is retired because the sensor data it relies on has significantly changed due to the introduction of new equipment and different operational conditions, leading to inaccurate predictions. This scenario primarily exemplifies which reason for model retirement? Option A. Cost optimization. Option B. Regulatory compliance. Option C. Model drift and performance degradation. Option D. Availability of a superior replacement model. The correct answer is model drift and performance degradation. Here's the explanation. The use case, model drift and performance degradation, directly describes a scenario where economic conditions or customer demographics have shifted significantly, or sensor data has shifted significantly, leading to declining accuracy, which triggers retirement. Question 15. During the model retirement process, why is an archiving strategy for retired model artifacts, associated data, and logs considered a critical and mandatory step? Option A. To continuously monitor the retired model's performance for a brief period after decommissioning. Option B. To immediately delete all related data to comply with privacy regulations. Option C. To ensure auditability, compliance, historical analysis, and potential future reference. Option D. To prevent the retired model from being accidentally redeployed in the future. The correct answer is to ensure auditability, compliance, historical analysis, and potential future reference. Here's the explanation. The study material explicitly states under Key Features Components, Archiving Strategy, Policies and Mechanisms for Securely Storing Retired Model Artifacts, for audit, compliance, and historical analysis purposes. The exam tips also highlight archiving is crucial. Understand that archiving model artifacts, data, and logs is a mandatory step for auditability, compliance, debugging, and historical analysis. It's not optional. Question 16. In the Git workflow, what is the purpose of the staging area, index, and which command is used to add files to it? Option A. It's the local repository where committed changes are stored, git commit, Option B. It's where you modify files directly, git modify, Option C. It's an intermediate area to prepare changes for the next commit, git add, Option D. It's a remote repository for collaborative work, git push, The correct answer is, it's an intermediate area to prepare changes for the next commit, git add, Here's the explanation. The How It Works section describes staging area, index. After making changes, you use git add to move specific modifications from your working directory to the staging area. This allows you to carefully craft your next commit by selecting exactly which changes you want to include. Question 17. Which statement accurately describes a key benefit of Git's distributed architecture in an MLOps environment? Option A. It requires a constant internet connection to access the central repository. Option B. Every developer has a complete local copy of the repository history, enabling offline work and resilience. Option C. It only stores differences between file versions, minimizing storage space. Option D. It simplifies conflict resolution by automatically accepting the latest remote changes. The correct answer is every developer has a complete local copy of the repository history, enabling offline work and resilience. Here's the explanation. The Key Features Components section states distributed architecture. Every developer's local machine holds a complete copy of the repository, including its full history. This enhances speed, resilience, and allows for offline work. Question 18. In MLOps, why is it crucial to utilize a .gitignore file, and what types of files would typically be included in it? Option A. To specify files that should be automatically committed to the repository. Source code files. Option B. To track large datasets and model binaries within the Git repository. All ML artifacts. Option C. To specify intentionally untracked files that Git should ignore, such as large datasets or sensitive credentials. Option D. To define merge conflict resolution strategies. Configuration files. The correct answer is to specify intentionally untracked files that Git should ignore, such as large datasets or sensitive credentials. Here's the explanation. The exam tips section explicitly mentions Git ignore file. Know its purpose, to specify intentionally untracked files that Git should ignore, e.g., large datasets, model binaries, environment files, sensitive credentials. In MLOps, this is critical for keeping large model artifacts or raw data out of the repository. Question 19. What is a key distinction between "git merge" and "git rebase" in an MLOps context? Option A. "Git merge" rewrites commit history, while "git rebase" preserves it. Option B. "Git merge" is used for feature branches, while "git rebase" is for hotfix branches. Option C. "Git merge" creates a new merge commit, preserving historical context, while "git rebase" creates a linear history by rewriting commits. Option D. "Git merge" requires manual conflict resolution, while "git rebase" resolves conflicts automatically. The correct answer is "Git merge" creates a new merge commit, preserving historical context, while "git rebase" creates a linear history by rewriting commits. Here's the explanation. The study material explicitly states, understand the core difference between git merge and git rebase. Merge preserves history, creating a new merge commit. Rebase rewrites history, creating a linear project history but should be used with caution on shared branches. Question 20. In MLOps, which type of Git branch is typically used to isolate experimental changes for a new model architecture or a specific hyperparameter tuning effort? Option A. Main/master branch. Option B. Hotfix branch. Option C. Development branch. Option D. Feature branch. The correct answer is feature branch. Here's the explanation. The Key Features Components section defines a feature branch as a temporary branch created for developing a new feature, conducting a specific model experiment, or implementing a new data transformation. Question 21. Why are Git branches considered lightweight and inexpensive to create in MLOps compared to traditional file copying? Option A. Git only stores the differences between files, not full snapshots. Option B. Git creates a new directory for each branch, which is optimized for storage. Option C. Git branches are simply movable pointers to commit objects, not full copies of the repository. Option D. Git compresses all branch data into a single binary file. The correct answer is Git branches are simply movable pointers to commit objects, not full copies of the repository. Here's the explanation. The How It Works section states, a branch in Git is simply a lightweight, movable pointer to one of these commit objects. When you create a new branch, Git doesn't create a copy of your entire repository. Instead, it just creates a new pointer. Question 22. What is the primary purpose of pull requests, PRs, in an MLOps context? Option A. To directly commit changes to the main branch without review. Option B. To formally request to merge changes from a feature branch into a target branch after review and validation. Option C. To solely track code changes for auditing purposes. Option D. To automatically deploy models to production environments. The correct answer is, quote, to formally request to merge changes from a feature branch into a target branch after review and validation. Here's the explanation. Pull requests in MLOps are a fundamental mechanism for collaborative development, enabling structured code review, automated validation via CI/CD, and explicit approval before changes are merged into stable branches, ensuring integrity and reproducibility. Question 23. Which of the following is an MLOps-specific automated check typically triggered by a pull request? Option A. Generic code linting and style checks. Option B. Model training validation, performance benchmarks, and data drift detection. Option C. Basic unit tests for utility functions. Option D. Manual deployment to a production environment. The correct answer is model training validation, performance benchmarks, and data drift detection. Here's the explanation. Beyond generic code checks, MLOps PRs trigger specialized CI/CD pipelines that include model-specific tests like validating training runs, benchmarking performance against baselines, and detecting data drift or schema changes, which are crucial for ML system reliability. Question 24. A data scientist has developed a new model algorithm on a feature branch and is ready for team review and integration. According to the typical pull request lifecycle in MLOps, What is the next step after pushing the feature branch to the remote repository? Option A. Directly merging the feature branch into the main branch. Option B. Opening a pull request specifying the source and target branches. Option C. Running a local performance benchmark on the new model. Option D. Deploying the model to a staging environment for immediate testing. The correct answer is opening a pull request specifying the source and target branches. Here's the explanation. After developing changes on a feature branch and pushing it to the remote repository, the next step in the PR lifecycle is to open a pull request. This initiates the formal review process, automated checks, and eventually the merge into the target branch. Question 25. How does an MLOps continuous integration (CI) pipeline primarily differ from a traditional software CI pipeline? Option A. MLOps CI pipelines only focus on deploying models to production. Option B. MLOps CI pipelines integrate code changes less frequently. Option C. MLOps CI pipelines extend their scope to encompass ML code, data, and resulting model artifacts, including data validation and model sanity checks. Option D. MLOps CI pipelines do not use version control for code. The correct answer is MLOps CI pipelines extend their scope to encompass ML code, data, and resulting model artifacts, including data validation and model sanity checks. Here's the explanation. The overview states, unlike traditional software CI, which primarily focuses on source code, MLOps CI extends its scope to encompass not only the ML code, but also the data used for training and validation, and the resulting model artifacts themselves. This includes unique steps like data validation and small-scale model sanity checks. Question 26. Which of the following is an ML-specific component or step critical to an MLOps CI pipeline? Option A. Running unit tests for general utility functions. Option B. Performing static code analysis for Python syntax. Option C. Data validation to check schema adherence, data types, and potential data drift. Option D. Packaging the final model for production deployment. The correct answer is, quote, data validation to check schema adherence, data types, and potential data drift. Here's the explanation. The key features/components, section lists, data validation, as a crucial ML-specific step, verifying incoming or updated datasets for schema adherence, data types, missing values, and potential data drift against baselines. Other options are either general CI steps or belong to CD. Question 27. What is the primary goal of an MLOps CI pipeline? Option A. To perform full-scale model retraining on a production dataset. Option B. To detect integration issues early, ensure quality and reproducibility of ML components, and provide rapid feedback. Option C. To manage the manual deployment of models to staging environments. Option D. To optimize the inference latency of deployed models. The correct answer is to detect integration issues early, ensure quality and reproducibility of ML components, and provide rapid feedback. Here's the explanation. The overview explicitly states, the primary goal of an MLOps CI pipeline is to detect integration issues early, ensure the quality and reproducibility of ML components, and provide rapid feedback to developers. Full-scale retraining is part of CT, and deployment is part of CD. Thanks for watching. Please subscribe to my channel.